Hi, in this video, I will be showing you problem number 11 of chapter 4 section 3 from the practice exam. Consider the equation below. f of x equal to x to the power of 4 minus 8x square plus 8. A. Find the interval on which f is increasing. Enter your answer using interval notation. Find the interval on which f is decreasing. Enter your answer using interval notation. B. Find the local minimum and maximum values of f. Find the inflection points. Find the interval on which f is concave up. Enter your answer using interval notation. Find the interval on which f is concave down. Enter your answer using interval notation. Part A is to find in which interval f is increasing. We know that f is increasing when the derivative is positive. So we have to find out the interval on which f prime is positive. So we will find out the derivative first and set that to 0. So f prime of x is the derivative of the given function, so which is 4x cube minus 16x plus 0. So we are going to set this to 0. So we can take common factor out, which is 4x times x square minus 4 equal to 0. On factoring, this would give us 4x times x plus 2 times x minus 2 equal to 0. So the critical numbers are, the critical points occur at x equal to 0, x equal to 2, and x equal to negative 2. So we can divide the interval into 4 parts. So negative infinity to negative 2, negative 2 to 0, 0 to 2, and 2 through infinity. So we are actually marking these points 0, 2, and negative 2 on the number line and dividing the interval. And we have to see in each one of these intervals what the sign of f prime is. So we can choose a test point in the interval negative infinity to negative 2. Our test point could be negative 3. So if I plug in negative 3 into this f prime, so I'll get negative 3. So I'll have a negative, then negative, that is negative times negative positive times negative, so that will be negative. So in this interval, f prime would be negative. And then we have to find out a value, test point between negative 2 to 0. I can pick a negative 1 here. If I plug in negative 1 into this f prime x, this is the value of f prime x. So if I plug in here negative 1, so negative, then I will have a positive, negative times positive, that will be negative, then negative times negative, that will be positive. So my f prime here would be positive. Then 0 to 2, I'm going to pick the test value of 1. So plug it in into this relation here. That is 4 times positive 1, positive. 1 plus 2, that will be positive. Positive times positive, so far it is positive. Then it will be negative. 1 minus 2, it will be negative. So in this interval, it is going to be negative. Then in the interval 2 through infinity, so I can pick test value 3. So it will be 3 positive times positive, which is positive, times positive. So that is going to be positive. So f prime is positive. So in order to verify what the sign of f prime is, you have to take the derivative, which is 4x times x plus 2 times x minus 2, and plug in the test values of each interval into this f prime x and see the sign. So we get these signs here. From here we can say whenever f prime is positive, or the derivative positive, the function will be increasing. F is increasing whenever f prime is positive. So f prime is positive in the two intervals -2 to 0 and 2 through infinity. So -2 to 0 union 2 through infinity, f is increasing. F is decreasing whenever the derivative is less than 0. So f prime is less than 0 on -infinity to -2 and then 0 through 2. So in these two intervals, f is decreasing and decreasing respectively. In the second part, find the local minimum and maximum values of f. So local minimum occurs whenever the graph is decreasing and then increasing. So f prime should change from negative to positive. That's where the local min will occur. Same way, local maximum will occur when f prime changes from positive to negative. That's where the local max occurs. So in this case, f prime decreasing and then increasing at -2. F prime changes from negative to positive at 2 as well. So at -2 and +2, the graph have local minimum. F prime changes from positive to negative at 0. So f has local max at 0. So local minimum occurs at x equal to -2 and +2, and local max occurs at x equal to 0. The question is local minimum and maximum values of f. So we have to find out f at -2 and +2 for local minimum value, then f at 0 for local maximum value. So we have to plug in -2 and +2 into the original function f, which is into this function. And then when we plug in -2 and +2, we get the same value -8, which will be the local minimum value. When you plug in 0 into the original function f, we get 0, which is equal to 8, which is the local maximum value. So local minimum value is -8 and local maximum value is +8. Part C is to find the inflection points. Inflection points are points where the graph changes from concave up to concave down or concave down to concave up. So concave up or concave down gets determined by the second derivative. So we have to find out the second derivative, f double prime x, which is the derivative of the first, which is 12x square minus 16. So setting this to 0, we get 4 can be taken out. So it is 3x square minus 4 equal to 0, or 3x square minus 4 equal to 0 would mean x square equal to 4 over 3, or x equal to plus or minus 2 over square root of 3. So now we have to divide the number line into 3 parts, 3 regions, -2 over root of 3 and 2 over root of 3. Place them in that order. Then we have to see what happens to the derivative, second derivative in these intervals. So when we compute 2 over radical 3, the value will be approximately -1.15. So we have to pick a test point between -infinity and -2 over radical 3, which can be given as -2. So if you plug in -2 into f double prime, which is this expression here, then we will notice that f double prime will be will be positive in this interval, then f double prime will be negative in this interval, f double prime would be positive in this interval, which will tell us the graph is concave upward in this interval. It is concave down in this interval, negative 2 over radical 3 to 2 over radical 3, and that it's again concave up in this interval. So we can say the graph is f is concave up on negative infinity through negative 2 over radical 3 union 2 over radical 3 through infinity. Then f is concave down on the interval negative 2 over radical 3 through 2 over radical 3. So the change occurs at the point, the change of sign for the derivative, double derivative, or the second derivative occurs at negative 2 over radical 3 and 2 over radical 3. So the x-coordinates of the inflection points could be negative 2 over radical 3 and 2 over radical 3. But when you say point, it denotes x-coordinate and the y-coordinate. So we have to determine the y-coordinate as well. So the inflection points, so if you determine f plus or minus 2 over radical 3, they will be the same, because if you look at the nature of the original function, it is an even function. So it has x to the power 4 and x square. So whether you plug in plus 2 over radical 3 or negative 2 over radical 3, it's going to be the same. If you plug in that value and use your calculator to compute that, you will find these are negative 8 over 9. So the inflection points are plus or minus, or you can say negative 2 over radical 3, negative 8 over 9, and positive 2 over radical 3, also negative 8 over 9. So whenever you find out the y-coordinates, keep in mind you have to plug in the x-coordinate into the original function f. Then second derivative of f will determine concave up or concave down, and then the inflection points. The first derivative will determine whether the graph is increasing, decreasing, and to find out the local max and the local min. Hope this video helps.